Okay, hello students, and welcome to our lesson on factorising monic quadratic expressions today. So we want to look at what we call a quadratic trinomial and factorise it back into a binomial product. Well, what does those two mean? Or what do those two mean, I should say. So remember when we were looking a couple of lessons ago, we had something like x plus 1, x plus 5, and we wanted to expand those. So I might as well do FOIL. So we'll look at our first terms. So x times x is x squared, and then we'll FOIL. The next one is O for outer, so we're going to go plus 5x. Then we'll do our inner. So that's plus 1x, or just x. And then let's do our last terms. And 1 times 5 is 5. So, what can we see? We can see that we can simplify these two terms because they're like terms. So this becomes x squared plus 6x plus 5. And so we can define two different things. This one over here with two brackets is a binomial product. Two terms or two brackets and they're multiplied together. So binomial for two terms. Over here we can see three terms. So that's a trinomial. 1, 2, 3 terms. Now the general form of a quadratic expression looks a bit like this. So let's just define a quadratic as well. And so if we have a look over here, to factorise a quadratic trinomial in the form of x squared plus bx plus c, okay, that is a quadratic. Identify two numbers m and m that multiply to give c and add to give b. That is x squared plus bx plus c equals m plus m x plus n. Are we going to look at a definition of quadratic? Oh well, that's our form of a quadratic, so let's define that as well. So the quadratic equation is a trinomial. So let's just say here, quadratic equation. Look, it takes the general form of x squared plus bx plus c. So the important thing here with a quadratic equation is we've got this little x squared component here. So we're going to use this to describe growth or things like that of rabbits in a paddock, for example, that they grow and grow and grow quite quickly. What else? Then we can summarise x plus m and x plus n. Now this is important, these m and n terms, because what did we say? That m times n and m plus n should give us b and c. So let's have a look here. So the two numbers m and n multiply to give c. So m times n equals c. So they equal that term there. But m plus n gives the value of b. Now let's have a look at that above equation here. We've got 5 and we've got 1x. So 5 plus 1 equals 6. Yeah, so that works well. And the other one is 5 times 1 equals 5. So let's try and factorise this quadratic now. It goes a bit like this, so we go. Oops, I don't need to put that brackets in. So in this case, I just want to x squared plus 6x plus 5. Now I've got this here. And I'm going to set up my brackets like this. Now the first term is x squared, so I put that in the first part of my brackets. Now I can see pluses all the way through, so that's going to be a pluses, but we need to work out what the final term or the last term in each of the brackets are. So what I need to do is think of the factors of 5. So I'm looking at the factors of the final term, the C term that is. So over here, factors of 5. Well, it can be 1 times 5, and that's the only options I've got, isn't it? So this is going to be x plus 1, x plus 5. So I'm going to work through a few of the definitions, and then we'll do a few more of these examples. Okay, so there's a difference of 2 squares rules. We'll look at that in a little bit, where it's just a squared take b squared equals a plus b, a minus b. So the important thing with the difference of 2 squares is that, yes, we have a square, and there's a difference, and there's a plus and a minus in each of those. Now, always check to see if you can take out a common factor first. Now, you can check to see whether you have factorised correctly by expanding the result by comparing it to the original expression. Okay, is that what we had before? X squared plus 6x plus 5. It looks like it. So I'm just going to work through a few of these examples here in your book, and here we go. So I'll just zoom in to an appropriate level so I can write a squared. So we've got a squared plus 11a plus 18. So what I need to do is think of 2 factors that equal 18. So over my right hand side, I'm just going, well, this has got to equal, first of all, a and an a because it's an a squared, a plus and a plus because they're all pluses. And then let's think about the factors of 18. Well, I've got 1 times 18, 2 times 9, and 3 times 6, 4, no, 5, no, 6, 3 again, so that's the same. So 2 numbers that multiply to give 18 and add to give 11. So it can't be 1 times 18 because they add to give 19. It'll have to be this one, won't it? Just check 6 plus 3 equals 9, and that's not the 11. So it's got to be 2 times 9, 2 and 9. So when we've expanded this, that's the expanded form there, and the factorised form is when it's in brackets. Let's look at this one. Y squared plus 7y plus 10. So that's the term that we're thinking about that we have to multiply. I'll find the factors of, but we can fill in what we know so far. So 2 factors that multiply to give 10 but add to give 7. So we think of the factors of 10, it's 1 times 10 and 2 times 5. Well, 10 plus 1 equals 11, so it can't be that one, it's got to be this one. 2 plus 5 equals 7. And there you go, that works. Let's have a look at another one. So we've got now a little bit more complex because we've got a plus and a minus. So let's see what we've got. M squared plus 2m take 3. M squared plus 2m plus 3. Now our m squared still goes at the front. So m times m equals m. And we're looking at our factors of 3. Of this case, so it's 3, and it's just going to be 1 times 3. Now, I think I've messed up because I needed to put in a negative on the final one. Okay. That had to be a minus, and this had to be a factors of minus 3. So I need to fix this up. So it's a negative 1 times 3 or 1 times negative 3. So which of these two multiply to give negative 3? Well, they both multiply to give negative 3, but add to give positive 2. Well, if I add those two together, I'll get a positive 2. if I add those two together, I get a negative 2. So it's got to be this one here. So I just take that negative 1, and let's just turn it into a minus 1, and the other one will be a positive 3. Let's have a look at x squared, take 7x, take 8. So x squared plus 7x, take 8. So x goes at the front. Now there's going to be a plus and a minus, and we'll work that out soon how that is. So I need to look at the factors of negative 8. So I've got 1 times negative 8, or negative 1 times 8. I've also got 2 times negative 4 and negative 2 times 4. Now let's see, well, if I add those two, they become negative 7. We want a positive 7, so it's got to be this one here. So it's got to be a negative 1 and an 8. There we go. Okay, let's look at this one. D squared, take 5d plus 6. D squared, take 5d and take 6. So, put in our brackets. The first term is d. Now let's see, if we've got two negatives, that's going to make life a little bit interesting. So let's think of the factors of negative 6. Well, I've got 1 times negative 6, negative 1 times, is that a negative or a positive 6? It's a positive 6. Oh, Mr. Beasley, get that right. So that's got to be positive 6, so that's got to be a negative, and that's got to be a negative. I could go 1 times positive 6 is, oh, yep. I can go 2 times 3, or negative 2 times negative 3. Now, which of these two add to give negative 5? So, it can't be this one. They add to give negative 7. That adds to give 7. That adds to give 5. These two here add to give negative 5. So it's D take 2, D take 3. Now, you can also be asked to verify, and we'll do this more in your senior work. Now, if we verify, all we do is we get this expression that we factorised and just prove that it equals this again. So you just expand it. So this is called a mathematical proof. So we just go, oh, D take 2, D take 3. And I think we used FOIL earlier before, so we might use a crab claw this time. So we've got D times D, take 3D, take 2D, and take 6. So let's write this out. So D times D is D squared. Then I'll do this one, take 2D. Oh no, sorry, I'll do the top line first. Take 3D. Then we'll do this one, take 2D, take 6. 3 times 2 is 6. Now remember, those are like terms. So we just collect the like terms. And notice that, yes, this is what we call our proof. We have verified that we've done it correctly. That's a good way to check your work, essentially. Okay. Let's have a look at this one. So this one's factorising by first taking out a common factor. So if I look at this one here, we'll write this in first. 2x squared, take 14x. Okay. There we've got, I'll find a better pen. 2x squared, take 14x plus 12. Now I think there's one like this, and it's an A-level question on your test for Year 9. What we need to do is find a common factor for all of these three terms, and you can see that they're all divided by 2. So this becomes x squared, take 7x plus 6. Now you can just treat it like you did before. You can ignore that 2 on the outside. We just put that there. And what have we got? 2. Set up our brackets like so. And so what do we want? 2 numbers that multiply to give 6 and add to give -7. So we think of our factors of 6. Well, 1 times 6, -1 times -6, 2 times 3, and -2 times -3. We want them to add to give -7. It can't be that one, it's got to be this one here. So let's put in our x terms. Okay, and it's going to be a -1 and a -6. So what makes this tricky is just pulling out that common factor out of the front. Oops. Now, the difference of 2 squares rule is really handy if you know your square numbers. So let's just think of our square numbers. We've got 1 times 1 is 1, 2 times 2 is 4, 3 3s are 9, 4 4s are 16, 5 5s are 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, and 12 squared is 144. So they're handy just to keep in mind that they are just square numbers. So let's have a look at our first one. X squared, take 25. So x squared, take 25. Well, that's going to be equal to the square root of x is x, and the square root of 25 is 5. So if we've got a 5 and a 5 there. Now the trick here is this is a difference of 2 squares rule. So we've got a +5 and a -5. Let's just expand this out and see what it actually looks like and why we can just take the shortcut from here to the first step. So if we go x plus 5, so we're just looking at the mathematical proof at the moment, x take 5. Now, I think I've done foil and I've done crab claw, so I'll do the rectangle method with you for this one. So we've got x plus 5 and x take 5. So the first rectangle becomes x squared, the one on the right becomes plus 5x, the one on the left becomes minus 5x, and 5 times 5, -5 is 25. So let's write this out. We've got x squared plus 5x, take 5x, take 25. And you can see that those two just cancel each other out. So it's just become x squared, take 25. We'll do one more and then we'll call it a day because this is quite a long one. So 4k squared, take 36. So 4k squared, take 36. Now, let's look at our first number here. What two numbers multiply to give 4? Well, that's got to be a 2 and that's got to be a 2. 2 times 2 is 4. Okay, k squared, well, that's got to be k and a k. And then we've got a plus and a minus. So, and 6 6s are 36. So it's a 2k plus 6 and a 2k minus 6. And I think that's enough for today.